In the last video, we looked at graphing a single linear inequality, which gave us a line, dotted or solid, and a region. So what we're going to do here is mix together that idea along with what we learned with solving systems of linear equations. So with our systems of linear equations, our steps were to graph both of the lines and look for their intersection point. What's going to change here is we're going to graph both of the lines and we're going to look for their intersection region. So we're going to end up with a shaded region as the solution. What I want to do is also emphasize how we can use the Desmos graphing calculator to help us out, along with how to input solutions into MyOpenMath. In fact, I'm going to start with MyOpenMath of just using the function to graph linear inequalities, just a single one. So at the bottom you have two options. There's the option to graph a solid line and graph a dashed line. And they give these symbols here, like you can see there are these three red dots. It's basically telling you what information it needs. And the order for these is you're going to graph the line first, and then you're going to choose a region. So my equation here is y is less than 3x plus 3. So let's see, it's a less than symbol, so I want to select that dashed line. And then 3x plus 3, so let's see, y-intercept at positive 3, and then a slope of 3. So I just need to grab a second dot. And then I need to, you just click on like above the line or below the line. Let's see, we're doing less than, so I would click on this right-hand side to be below the line. So that's how you'd input a solution. They did write out the steps here, but it can be nice to see that for how to input those correctly. Then what we'll do is I'm going to find an example that has two of them, which will be the similar process, and I'll show you how to go about entering that into MyOpenMath. Okay, so let's talk about systems of linear inequalities. So with these, you're being given two linear inequalities, and sorry, the separation of these might be kind of hard to see. So for this one, we have x is more than -4 and y is less than or equal to 2. So we want to graph both of these. So let's start with x is more than -4. So if I was graphing x equals 4, that would be a vertical line. And it would be a vertical line at -4, so something like that. But we just have the more than symbol, so that means I want to use a dashed line. So at x equals -4, I'm going to have a dashed line going vertically up and down. So there's one, and then I am going to make a note of which region I would shade. So we want the x values that are larger than -4. So with that, I would want to be shading to the right-hand side of this line. So what I'm going to do is just draw myself some little arrows to show we're shading to the right of that line. Then I want to graph y is less than or equal to +2. So if I graph y equals 2, that's a horizontal line. And this would be a solid line since we can equal 2. And then we want the y values less than or equal to, so I want to shade down from that line. So what we want to do is look for the intersection of these two pieces. What region is to the right of our vertical line and below our horizontal line? And that's going to be this kind of square over here. So in terms of shading an answer, that's going to be my answer. It's just this region where the two overlap. And that would be our solution. All right, let's do a few more examples of these. So we're going to have y is less than -x plus 2. So let's see, I'm going to graph -x plus 2. So y-intercept at +2, a slope of -1. And with that, so I'm just graphing some dots so I can make it nice and accurate. And let's see, y is less than, so we're going to use a dashed line. Oop. That's why I like to use more than one dot, is because sometimes it can mess up. There we go. All right, so there's our dashed line for y equals negative x plus 2. And then we want less than, so we want to be shading below. And I'm just going to draw myself a few arrows to show we're graphing below that. And then I also want y is more than or equal to 3x minus 4. So I'm going to have a y-intercept at negative 4. And then a slope of positive 3. And let's see, we're going to use a solid line for that one. Ooh, if I can draw a straight line. All right. Straight-ish line. And let's see, we want more than or equal to that. So with that, we want to be shading above. So where these two intersect, so we're below this line, it's below this negative x plus 2 line and above the 3x minus 4. So we are going to shade in all of this region. And those would be all of our solutions. All right, let's do this next one as well. So y is more than x minus 3. So we have a y-intercept at negative 3, a slope of positive 1. And since y is more than this line, without the equals, we want a dashed line. And then I want to graph, let's see, y is more than, so I want to have the shaded region above that line. And then y is less than or equal to negative 2x plus 3. So with this one, we're going to have a y-intercept at positive 3 and a slope of negative 2. And then we will have a solid line since we have y is less than or equal to. So with that, we'll be shading below. So we want the regions that is below the red line and above the blue line. So with that, we're going to have this wedge on this left-hand side of those two pieces together. And that's our system of linear inequalities. So graphing the two lines and then finding that region where the two overlap with each other. Let's go to MyOpenMath and see how we plug it in there, and then I'll show you on Desmos as well. So for this one, oh, this is a tricky one. Actually, I'm just going to show you with that last one. I'm going to ignore getting the correct answer within MyOpenMath, but just to show you how we would graph that last example. So graphing that y is more than x minus 3, so I'd grab the dashed line, do a y-intercept at negative 3, and then we have a slope of 1. And then I need to choose the region to shade, which would be above. And then we're going to have the second line is a solid line, and that y is less than or equal to negative 2x plus 3. So we're at positive 3 and a slope of negative 2. And then we're going to choose a region to shade, and in this case it was below. And that would be done. This is giving a representation of where those two shaded areas intersect would be our solution. Similar thing happens in Desmos when we graph these. So if I graph y is more than x minus 3 and graphing y is less than or equal to negative 2x plus 3, what we're going to see is there's a region where nothing is shaded, and that's because it's not a solution to either of the equations. And then we have these regions that's like just shaded in red, just shaded in blue. In those cases, that's where it's a solution to one of the inequalities, but not the other. But then this region to the left-hand side here, it's an overlap of the two. So it's an answer to both of the systems, and that's what we want. All right, let's take a look at an application here. So we have a company produces a basic and a premium version of its products. The basic version requires 20 minutes of assembly and 15 minutes of painting. And in fact, I'm just going to make little notes to myself, which can be helpful with these word problems, especially as we get more and more information. So let's see. For the basic version, it's 20 minutes assembly, 15 minutes painting. And then we're going to have the premium version, and that takes 30 minutes of assembly, 30 minutes of painting. Okay. If the company has staffing for 3,900 minutes of assembly, 3,300 minutes of painting each week, how many items can they produce within the limits of their staffing? So what we're going to do is look at how assembly relates. So let's call basic X, premium Y, and what we'll have is, let's see, 20 minutes for basic, for assembly. So that's going to be my first equation here. So for assembly, 20 times X plus 30 times Y for those 30 minutes of assembly for the premium version. And let's see, our limit is 3,900 minutes. So we need to be at less than or equal to 3,900 minutes. So that's just their maximum that they're setting. So we can be equal to that amount or less than, and that's fine with their staffing. And then for painting, we have 15 minutes of painting for basic, so 15 times X, plus 30 minutes of painting for premium, so 30 times Y, and the restriction for painting is 3,300 minutes, so we want that to be less than or equal to 3,300. All right, so we're going to graph these, and what I'm going to use the intercept so I can get an idea of what to use for my axes. So this first equation, so for assembly, I'm going to just set up a little table, X and Y, and I'm going to have two coordinates, one where X is 0, one where Y is 0. So if I plug in X equals 0, we're going to have 30Y, and just for simplicity, I'm going to say equals 3,900. So we're going to divide both sides by 30, and that should be 130, I believe, but I'm just going to double check with my calculator. Yeah, 130. All right, and then if I let Y equal 0, so that's 20X equals 3,900, so I want to take 3,900 divided by 20, and that's 195. Oops. Nope, sorry. Okay, there we go. Sorry, the menu got in the way there. All right, 0, 130, and 195, 0. Sorry, I realized I just turned the volume all the way up on my computer, and I don't want to scare you if anything pops up. Okay, there we go. Okay, so I'm going to graph those two coordinates for that line. I'm just going to make a note off to the side here that we're going to have 0, 130, and 195, 0 for my assembly line. My line for assembly. And then for painting, I'm going to do the same thing. So make a little table with X and Y. We're going to have X equals 0 for 1 point, Y equals 0 for 1 point. So if X is 0, then we'll have 30Y equals 3,300, and Y should be 110. And if we set Y equal to 0, we'll have 15X equals 3,300, and 3,300 divided by 15 is 220. All right. So what's nice about having these coordinates that are going to be graphed on our axes is that then that gives me an idea of what numbers to have showing up on my X and Y axes. So let's see, we're going to have 0, 110, and 220, 0. Okay, so I'm going to set up X and Y axes. And with that, I'm going to choose some numbers. So let's see, for the x-axis, I want to see out to 130 and 110. Let's try jumps of 10, see how that works. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Okay, that should be good. So my two coordinates, so from the line for assembly, let's see, I'm going to use blue for the line for assembly. So let's do, it would help immensely if I actually did my axes correctly. Sorry. That's one more time. The x-axis, I want to graph 195 and 220. So let's see, jumps of 10 probably won't work. So let's do every 2 blocks equals 50. We just want a visual for our answers. So let's see, 50, 100, 150, 200, 250, 300. That should be good enough. And then along the y-axis, I'm just going to do the same along the y-axis. It'll be a little messy, but it should be fine. 50, 100, 150, 200. Okay, so for assembly, we're graphing 0, 130. So let's see if that's 125 in between those. That's about 130. And then for the y or x-axis, ooh, they're mixing up in my head today. 195, so that's pretty close to 200. And then we would just connect those with a line. And again, there's this kind of implied we're going to only be in the first axis here, or sorry, first quadrant here, because we're hiring for work, and so we expect them to do some work, and you can't have negative amount of work happening here. Okay, and then, painting, 0, 110, which is maybe about there, and then 220, which is maybe about there, and then connect those with a line. All right, and we want to be shading below for these. So we want values that are below those, since it's all about being less than or equal to. So the region where they overlap would be kind of stuck underneath both of these lines, but also in the first quadrant. So we end up with, it's not really a triangle because we do have this corner right here where the two lines intersect. Almost looks like a triangle, but it's really a quadrilateral of a shaded region that's in this corner with the origin included.